the basic definition of equijoin and the basic example we discussed in the last class. Okay. So in this, what is the last class here, last example? I want to display students and their corresponding course details from students, course tables by using of equijoin. Okay, no? Right. And here I said that joins can be in two formats you can write. One is a non-ANSI as well as a ANSI. Okay. And what is the differences of this ANSI, non-ANSI means compatibility is difference like portability. Non-ANSI joins are not a portable, but ANSI joins are portable. And these statements can be moved into any database without any changes, without any modifications. Okay, no? So that should be advantage of ANSI. Okay, right. And the next one, in this examples, what it was happened here, I'm just going to displaying student and their corresponding course details. Okay, the student and their corresponding course details. That's it. And as per my condition, as per my condition, the student corresponding course will be displayed. Okay, now as per my condition. But how this condition will be work? Okay, how internally this condition will be checking? Okay, in your ANSI or non-ANSI, how this condition, how the data can be comparing internally means there is one. Okay, let me come out and see. So yesterday we designed two tables. One is our course table and one is our students table. Okay, now, so this is my condition. What is the condition here? S.cid is equals to C.cid. S.cid is equals to C.cid. So how this condition values will be checking? For example, S.cid, student CID column is equals to course.cid. In this column, okay, student, what it was there, 1, okay, 2, and null. And the next one here, when you come to in the course table, okay, we have here course ID, okay, 1, then course name 2, course ID 2, and course ID 3. So these are two tables information. See course IDs of your course table and course IDs of your student table. Okay, now? Right. So after that, you can come back and see what it was happened here. Observe the two things we have it here. Okay, now. So now how it was verified here means it was checking like each and every row as per the given condition, each value of a table is comparing with each and every value of another table. Understand? Another table. Okay, so each value of a value of first table is comparing with all values of your second table. So in this comparison, you can see 1 is equals to, my condition is equals to. So 1 is equals to 1. 1 equals to 1, condition true or false? Condition will be true. So true means this row will be joins together. Okay. Next, 1 is equals to 2, condition false. 1 is equals to 3, condition false. That's over. Same as second value also you can compare. So 1 is equals to 1, condition true. So condition true means this row is also joined. And 1 is equals to 2, okay, false. 1 is equals to 3 is also false. Okay, now next, second one you can see. So now second one. Second will comparing here. 1 is 2 equals to 1, false. 2 is equals to 2, condition true, then this will be join. Okay. And 2 is equals to 3, false. And null. Null we can compare here. Null, okay, 1. Null is equals to 2. Null is equals to 3. Okay, now. So in this comparisons, how many matching? 1, 1, 2 times matching here. 1, 1, 2 times matching. Next, 2, 2 matching. Okay, now, so this is your final output. Okay, right. This is what it was happened. And finally, same output we got it now. Okay, so whenever we return the condition here, select a star from students. Yes, either you can say equijoin. Okay, so course C, where class S dot CID is equals to C dot CID. So same output is came 1, 1, 1, 1, and 2, 2. Okay, now? Right. So now if you want to use in your ANSI format, so in place of this comma, I'm using what now? Inner join. And now in place of this where class, I want to use on class. So here also same to same output. Okay, no? So how internally it was, okay, internally how it was working, your equijoin condition, whatever it was given, how it was working, now you got it now? Come on, guys. Now understand how this query internal executed. Okay, so that means here, what I want to say, there is a one rule was there here. So rule of joins. So what is my rule of joins means how the joins are working in any join, not only equijoin. So any join, it was working like this only. Okay, this is a common rule of your joins. What is the common rule means? A row in a table is comparing with all rows of another table. Okay, a single row in a table is comparing with all rows of another table. Okay, so this is what the rule of join. Suppose when you got confusion in equijoin, inner join, non-equijoin, self-join, if any confusion was there, so this rule will be followed, and each and every row you can go to compare with your condition. Then you can easily understand that how the joins are working. Okay, and this rule, don't forget it. Okay, whenever you have any confusion or you didn't understanding that query, okay, then you have to follow this, automatically you can understand. Okay, this is a simple hint for you how the joins can understand to us. Okay, right. So next example, here observe. In this example, all people are coming to us. But what is my next example in this? Write a query to display students. Okay, to display students who are selected Oracle course. So in this, the second example, what I'm asking, okay, I want to know it. How many students are selected? That means who are selected. Okay, Oracle course. The specific course, how many students and who are selected, that information I want it now. Okay, now? Right. When I wanted this, then what I want to do, first of all, as usual, you need to write here, select a star from students. Yes. And first I'm showing non-equi. Okay, it means non-ANSI format I'm showing. Course C, where first the two tables I need to join. So up to here, we called as a join condition we written. And based on this join condition, how many matchings are there? That all matchings will come to us. But in this matching, other technology people also come to us. Okay. So that means all technologists, how many technologists people, their course IDs are matching, then all are coming to us. But in this, I don't want it other than Oracle. I want it only Oracle, not Java. So I want to remove this Java, and I want to know how many students are selected Oracle course. Okay. Then what we want to do up to here, we called as a join condition. And I'm writing second condition. What is my second condition? Course name is equals to who you want it, Oracle. Okay, who you want it, Oracle. And now you can see only Oracle people came us. And this is second condition we called it. This condition is called as a filtering condition we called. Which condition, people? Filtering condition we called. Okay. And in between filtering condition, which operator I'm using here? AND operator. AND operator means what now? So this is 1. This is 2. Okay. 2 conditions here. AND operator, when it was written true. Come on, guys. AND operator, when it was written true. When both conditions are true. When both conditions are true, okay, first condition true, second condition is also true, then true. Okay. First condition is what now? S dot CID is equals to C dot CID. Okay. S dot CID is equals to 1. 1 equals to 1. C dot CID. So 1 equals to 1. So first condition true. And their course name is Oracle. So second condition is also true. So here also second employee, Alan. Alan is also first condition true, second condition true. So both are true. Then the both people data came us. Okay, na? So this is what the second, okay, to finding only the people who are selected Oracle course. And this is the format of a non-ANSI. This is the format of a non-ANSI. And the next one is called as a ANSI. The next one is called ANSI. ANSI, how to write here? So just I want to add my inner join in place of where should be passed on class. That's it. This is ANSI format we called. Okay, now? Right. So now take one more example, for example. Next example is what? Write a query to display. Okay. Sum of salaries of departments. Sum of salaries of departments from EMP, DEPT tables by using equi-join. So in this, the query first understand, guys. So now tell me, the query is clear now? What I'm asking here, what we want to do now? Yes. So we need to display sum of salaries of departments. Okay, from EMP DEPT tables by using of equi-join. Now come out. First come to select a star from EMP table. You can see. In EMP table, can you find out here? Is there any departments are there here? Do you have any departments here? No. So we don't have department number is there, but department names are not there now. So there is no departments here. Okay, now? So there is no departments here, this table. So departments are where it is here, another table. Another is what now? DEPT table. So in DEPT table, you have a departments, accounting department, research, sales, and operation. Okay, now? So these are what we called as a department names. Got it up? So now what we want to do, guys, here, based on these departments wise, okay, based on these departments wise, I need to find out sum of salaries. Okay, so that means the salaries are having into one table and departments are having into another table. Got it my point now? So now you can go to compare now. But before you need to find out the sum of salaries of each department names wise, first these two tables I need to join. These two tables I need to join. When you want to join these two tables, what should be I want to check it out? If I want to join these two tables, okay, what should be there? Yes, common column should be find out. And see, do you have any common column in this table? Yes, department number is a common column is there. So based on this common column, first we need to write a join condition here. Okay, right. First I'm writing join condition. So select star from EMPE, comma DEPTD, where E dot department number is equals to D dot department number. Okay. Now up to here, if I just done what it was happening, you can see. Suppose I want to set my lines any. Okay, carefully observe. Here, so departments names are there. Carefully observe. Department names are there. Okay, so how many as equijoin? How many here? 20, 20, matching 30, 30, matching 30, 30, 20, 20, all matchings like. Okay, my equijoin here. What I'm asking my equijoin? Equal operator. Up to here. So the department number, employee table department number will how many times match with the department number of a DEPT table? So first we want to check it out. Now we can see all our matchings showing 20, 20, 30, 30, 30, 30, 20, 20, 30, 30, like all matchings are showing us. Total 14 rows will be matching here. Okay, but okay, matchings are showing because I'm using equal operator. So 40 is not showing. Why 40 is not showing here? Any reason? Yes, 40 is not a matching row. Okay, 40 is not a matching row. Okay, fine. So up to here, okay, the two tables data based on department numbers, I was join these two tables. But what should be required here? Departments wise, the sum of salaries I wanted. So departments wise, the sum of salaries I wanted. That means here department name column is there. After combination of these two tables data, your department name is there. Now tell me guys here, if I want to find out sum of salary of each department names wise, what should I want to do? How to find out the salaries of each department? Yes, we need to use what now? Group by. Very good. And now see, I'm applying group by here. So I'm going to apply here group by. Select star from EMPE, comma DEPTD, where E dot DEPT number. First, I want to join. Okay, na? So this is join condition compulsory. Then D dot department number. After joining, what I want to use? Group by department name. Okay, na? So now here, same as here also I want to change now. Yes, I want to change department names. sum of salaries. Now I executed this one. So the sum of salaries of departments are displayed. So research, okay, sales, accounting. So these are what we can say. Can you see how many departments we have in this? How many departments here? You can see. Research is a one department, sales, accounts. Here, accounts, how many accounts are there? Can you find out here? Accounting people, 10, 10, accounting matching. So again, this person is also matching. And this person is also matching. And their salaries are how much? 1,300, 5,000, 2,450. So on these three values, that means 2,450, 5,000, 1,300. So what I want to do, sum together. Okay. So sum together, how much it was? 7,000, 8,000. So 8,750. So 8,750. This is what it was happening. Okay. Right. So now this is how it was. And that 8,750, we got it. Okay. So first two tables are joining. After joining of the data, we applied a group by. Okay. Now this is up to here joining 2020. This is joining data. On this joining data, I'm applying group by on department name. In this department name column, how many different departments are there? Every department will be separated. Every department will be separating here. Okay, now. So after separated, there are three departments. That means three groupings are happen. So first group research, second group sales, and third group accounting. Okay, now after grouping, then we are apply sum of salary function. Okay, right. So these are, so another example of equijoin, how to get now. Okay, so this is, okay, if I show, this is non-ANSI. And same thing if I want it ANSI. So same thing. But what I want to do in this ANSI, just keys I'm going to change. Everything is same. So here I want to send my inner join. And here I want to give it a on class keyword. Okay, now. So this is what we can go to right. Another example, next example, observe. What is my next example here? Write a query to display. Write a query to display departments. Okay. In which department sum of salary is more than 10,000 if I'm giving. So if I was given more than 10,000. Okay, now. So now tell me, up to here grouping is done, and each and every department names wise we find out total salary, that is sum of salaries. But next my question is what now? In which department sum of salary is more than 10,000? Yes or no? Now tell me, which department is like that? Research department is there. Okay, right. Now after grouping the data, if user want to perform, okay, some operation, which class we need to use? Having class. It's very good. So now here I want to add having. I want to add having. What I want to ask here, sum of salary which is greater than 10,000. Okay, so if I was given that, then it will be taking this. Okay, now. So this is 10,000 above departments we find out here. Same as this is non-ANSI. Same as this is ANSI. Okay, right. So like this, you can perform your equi-join. Okay, to first your tables are joined with some equal operator. After joining the tables data with an equal operator, then we called as a equi-joins we called. Okay, no? Right. So next we are observe non-equi-join. So what is non-equi-join means? It's a quite opposite of your equi-join. So what we said, equi-join is going to be retrieving the data based on equal operator. So joining the tables based on equal operator. Okay. Okay, that is called a equi-join. But non-equi means the quite opposite now. Okay, so when we retrieve data from multiple tables, based on any condition, so based on any operator, condition, based on any operator condition except and an equal operator, Okay, except equal operator, you can use any operators on these two tables of data. Okay, first I will show you some examples. Observe. So which kind of operators means I can use less than, okay, now greater than, less than or equals to, greater than or equals to, okay, so not equals to, okay, end operator, between operator, etc. So any operator you can use, guys, but don't use a equal operator. Okay, now. Okay, fine. This is what it was happened. Let me see. First, I will show you a normal, simple, very simple example. I will show you first mechanism understand. Then after we will go for another example I'm showing now. So first I will check it out. How many tables in my tab list? So these are some tables already there. Okay. And few tables I'm going to drop now. Okay, right. First I will create a table. Create a table. Test number 1, carefully observe, a small table I'm taking. Int and name was varchar2 of a size. So this is one table. And into this table, now I'm inserting some data. So 10 comma, the name is Smith. And the next one is called as here 20 comma Allen. Okay. The second table I'm creating here. Second table name I'm changing now. And here some columns I want to take here, for example. Salary with number type. Okay, this is second table. So into this table also, I'm inserting some data. Values. I'm passing 10 and 25,000 salary. 30. 34,000 rupees. So your two tables I designed here, test one and test two. Test one table. This is some information. Test two table. Okay. So on these two tables of data, now I want to apply equi-join. Okay, I'm going to apply what now? Non-equi-join. So how to write non-equi-join on this? Okay, let me come. So select a star from test one, T1. So non-NC format, test T2, where T1 dot serial number. See, if I'm using equals to T2 dot serial number. If I'm using this is which join, guys? This join is called as what? Yes, it is called equi-join. It is called as what now? Equi-join. But I want it what now? Non-equi-join. So that's why don't use this. Instead of this, you can use, for example, greater than. So greater than or less than or equals to whatever you can use. So after executing of this query to see your final output, what it was comes observe. Anybody guessing which people data will get? $20 and $30, yeah? Now we can see it will be getting here. This is what wrong spelling, test number 2. So 2010 was come out. Okay. So again, same, I already explained to you. What I want to do whenever you have a confusion, the same condition, whatever I was given, this is my condition, right? So this condition, you will take it now. T1 serial number greater than T2 serial number. T1 serial numbers, what it was there? Check it out. 10 comma 20. Okay, now. But whereas come to, okay, T2 alias name serial number, you can see. So what is this? 10 comma 13. And what I said, each and every row you need to compare. Okay, now that is the rule of joins. And now as per compare here, which symbol greater than symbol? Greater than symbol. Now tell me, 10 is greater than 10. Condition true or false? Condition false. Next, 10 is greater than 30. Condition true or false? Condition false. So there is nothing here. Okay. Next one is what now? Second one. 20 is greater than 10. 20 is greater than 10. Condition true or false? Yeah. Condition true. So condition true means my output is what now? 20 is greater than 10. So this is correct condition. Next, 20 is greater than 30. So this is also okay. False here. And finally, 2010 is came. Now understand now? Okay. So same thing. Remember. So same as and these are the two tables I'm giving to you. Okay, right. So this is finally you got it, your output. Okay, right. And the next example, take it here. Write a query to display employees whose salary is between low salary and high salary. Low salary and high salary. Okay, so this question clear, all of you? Are you clear this question? So which employees I want to display, guys, here? Whose salary is between low and high. So which employee salary is between, that means it comes under between low and high. Okay, now we can see. So now, first of all, come to your EMP table. So tell me, guys, here in this EMP table, you have you have your complete employees information. And that employees are how many employees here? 14 employees we have. Okay. So 14 employees salaries are we have it. But we don't have a low salary column data, high salary column data. That means your low and high salaries are where it is now. In another table. in another table. So the another table is what now? Sal grade. In sal grade, can you see in the sal grade, I have a two columns here, low salary column, high salary column. Low salary columns are having low salary 7, 12, 14, 2, 3. High salaries are 12, 14, 2000, 3000, 9. Okay, na? These are low salary, high salary. So out of 14 employees, how many employees' salaries are comes between low to high salary? Low to high salary. Okay, na? So this is one more table. Is a default table I already sent to you. This is a demo tables. I already uploaded a demo tables documentation. In that, this table is there, sal grade table. Okay, na? Right. So now after that, okay. So here observe. Suppose if I want to go for first employee compare, 800 is there. 800 comes between low and high comparison. So first value comparing 7 to 12. Tell me, 800 comes between 7 to 12? Yes or no? 800 comes between 700 to 1200. In between comes here? Yes. So that means this is called a true. This is called a true. Next, 800 comes between 1200 to 1400. No, it's not comes between. So next 14 to 2000. No. Next 2000 to 3000. No. Next 3000 to 9. No. So that means your 800 is going to be satisfied the first row in the table. Yes or no? Like this, each and every row you can compare with the low and high salaries. Compare with the low and high salaries. Then see how I'm writing your query. Select employee name, salary, low salary, comma, high salary from EMP, comma, sal grade is a one more table. So where what I said here, the conditions, okay. My first condition, okay, where sal, can I write here sal between operator I'm using, sal between low sal column and high sal column. Can I write now? Come on, guys. Can I write like this? Yes, definitely. And now you can see output. Each and every employee's salary. This is salary, low and high. So each and every employee's salary, okay, is it comes between low and high now? Okay. See, 800 comes between 7 to 12 satisfied, 950 satisfied, 1100 satisfied, 1250 satisfied, 1250 satisfied. So each and every employee can see that employee salary comes between low and high. Okay, so this is what we called as a non-equi-join. That means you can see in my where class after I'm using any equal operator in this condition. No, there is no equal operator, but I can use between operator, and operators, yes or no, greater than operator, less than operators I can use. But the same requirement, can I write like this now? Same requirement, can I write like this now? Instead of between operator, can I write like this now? Salary which is greater than or equals to low salary, end operator, another condition, salary less than or equals to high salary. Can I write in place of between operator? So yes, we can, and C2 execute now. Same output is come to you. Same output is come to you. So this is the way you can go to use your non-equijoin. I'm not using. So non-ANSI, either this one or else you can use the next one. What is the next one here? Either this or this. Come to ANSI. If you want to write ANSI, then you can write like this. But ANSI, what I'm saying here I want to use a join key. Okay, here I want to use a join key. In place of this on, you can. Same as here also you can use join key. In place of where you can use on. Okay, so these are what now? Non-equijoin, you can use any operator you can use, but don't use a equal operator. So that's why here I'm using greater than symbol. Okay, and now we can go for to arranging some between operator. We are using greater than or equals to, we are using less than or equals to, we are using AND operator. So like we can go to apply this. Okay, na? Right. This is non-equal. So except equal, you can use any other operators in this join. Okay, right. Next one. So next one is what now? Outer joins, you can see. Outer joins. So basically outer joins when we required means that, can you find out guys here? in my equijoin, okay, in my equijoin, we are getting which kind of rows? Matching rows or unmatching rows? Equijoin is always returns which rows? Matching rows. So equijoin will returning only matching rows. That means if in your table, in your tables, if any unmatching rows are there, that unmatching rows are not retrieval for or not retrieval by equijoin. Yes or no? Equijoin will not retrieve unmatching rows. Equijoin will retrieving only matching rows. Got it my point now? Right. So, sir, here one matching will come again, one matching again come, two matching will come. But your 3 is a unmatching, your null is a unmatching. These unmatching data also we need to retrieve. Then how we can? Means there you want to use a outer joins mechanisms are using. Okay now? Now what I'm saying here? What I'm saying here? Generally, equijoin, retrieving matching, retrieving matching rows or data from multiple tables. Multiple tables, but not unmatching rows. Or data. Okay. So generally equijoin retrieving matching rows only, but not unmatching rows. Then what we want to do means if we want to retrieve, you want to retrieving, matching, and also unmatching rows, okay, or data from multiple tables, then we use which joins here, outer joins mechanisms. Then we use outer join mechanism. Okay, na? This outer join, this outer joins, or this outer join, again classified into 3 types. Okay, first one, left outer join. So left outer join, what it will do, sir? Which kind of data will be getting from, okay, left outer join means left outer join, okay, is used for to retrieving all matching rows from both the tables, and unmatching rows from left side table only. So matching rows are from both tables. So matching rows are taking from both tables. Okay, and unmatching rows taking from only left side table. So that means the right side unmatching rows are not getting. This is what we called as a left outer join. Understand now? Definition is clear, all of you? Okay, now? Right. So this is left outer join. Let me come out and see carefully. Select a star from course and select a star from student. Okay, these are 2 things. Now I'm using on these 2 tables left outer join and follow it here. Select star from students left outer join. Here S alias names I'm taking. Yes, alias name. And second one is what now? Course C. The condition, it is an ANSI format. That's why I'm using on class. Condition is what now? S dot CID is equals to C dot CID. Now you can see in my query, students left outer join course. Tell me which table in the left side direction in the query? Which table is having in the left side? Student table is in a left side. So student table is in a left side. That means what I'm saying here, matchings are there. That means matching rows, whatever it was there, 1, 1, 1, 1, 2, 2. Matching rows are we are getting from both tables. Matching rows are we are getting from both tables. But unmatching rows are, unmatching row means here what now? Null. Null is unmatching row. Unmatching row is getting from left side table. Left side table is what now? Student. Student is a left side table. So left side table data only we got it. Okay, now? So this is left outer join implementation, guys. And which format here? ANSI format. Okay. But sir, how to write a non-ANSI format? How to write a non-ANSI format? Here carefully observe. Whenever we want to write outer joins in non-ANSI format, directly we can't write. That's why we want to use one special operator that's called as a join operator we want to use. Okay, now, so what I'm saying here in the non-ANSI, here observe. When we want to write outer joins in non-ANSI format, then we should use a join operator. Okay, a join operator is, now you can see, open bracket plus and close your bracket. This is called as a join operator. Okay, this operator should be used only in outer joins. And in outer joins, which format? Non-ANSI format. So whenever you want to write outer joins in non-ANSI, so there should be used what now? Okay, this join operator. Got it my point now? But how? When I'm using join operator, what it was happened, sir, means this operator on which table you kept, from that table, it was retrieving only matching rows. Okay, this plus operator on which table are you kept? From the table, only matching rows are retrieval. That means unmatching rows are not retrieval. Okay, for example, you can see here what I'm saying here, left outer join. So how to write left outer join? Here observe. Select star from students S, comma, course C, where S dot CID is equals to C dot CID. If I'm leaving like this, what happened? It is called an equijoin. But now equijoin means what happened? Only matching data will comes to us. Only matching data will come us. But I want to do what now? Not only matching, I want to get a unmatching also. So unmatching of which side I want it? Left side. That means left outer join. Left outer join means what I'm saying here, left outer means your join operator will apply on the right side of your table. Right side of your table you can apply. So when you apply in the right side, what I'm saying here is quite opposite. Okay, now left means right side apply, right means left side apply. Quite opposite. Okay, now remember, quite opposite. So I'm implementing which join? Left outer join. So left outer join, if I implement, my join operator should be in the right side table. And from the right side table, what I said, on which table this operator will be used? From the table, it will be retrieving only matching rows. That means unmatching rows from course table, we are not getting. We are getting only matching rows from course table. But student table, we are getting matching and also unmatching. Okay, because I'm saying what now? If I'm using join operator, on which table I'm using, from the table, it will be retrieving only matching rows. Okay, so that means I was applied my plus operator on which table? Course table. That means from the course table, what it was get? Matching rows only get. Unmatching rows will never get it. So that means my left outer join implemented or not? See. So this is actually left outer join ANSI format output. Same below. Select a star from students S, comma, course C, where S dot CID is equals to C dot CID of the join operator I'm using. So when I'm using join operator, what happened? You can see. Tell me your ANSI left outer join result Non-ANSI left outer joint results. Both are same. So that means your left outer joint successfully implemented in non-ANSI format. Is it happened? Okay, now so your small hint what it is. Left outer means apply your join operator on right side table. Right outer means apply your join operator on left side table. Okay, on which side table? On which side table you applied this? From the table, only matching rows are retrieving. See, my plus operator I'm using on course. Then from the course table, which data is came? Matching data na, unmatching data na? Come on. Which data is came from the course table? Yes, matching data will come here. So this is what it was happen. Okay, right. This is the way how I'm using in non-ANSI. Same as come to right outer join also I'm using. Come to right outer join. In right outer join, how it was working here, observe. Retrieving all matching rows from both side tables or both tables and unmatching rows from right side table only. Right side table only. Now here also come out. So now I'm passing. Select a star from students, and here my keyword is right outer join. Okay, then course C on class S dot CID is equals to C dot CID. Spelling wrong, huh? Okay, right. Alias name, you forgot it. So now in this case, what it was happening, you can see student and course in this two table. My right side, I was kept into course table. And it is a right outer joint. Right side course table is there. So course table getting matching rows and unmatching row also. But left side table is getting only matching rows. That means matching rows from both tables we are getting. But unmatching row we are getting from right side table only. That is called a right outer joint. So this is okay, fine. It's my non-ANSI format. But can you tell me the same thing into ANSI? Come on, guys. Can we write an ANSI format here? How to write ANSI format here? So this plus symbol I want to keep on the right side or left side? This join operator on which table we want to apply? Yes, quite opposite. So I want to apply on the left side table. Okay, fine. And see. So both outputs correct now? ANSI, non-ANSI, both are providing same results now? Yes. Okay. This is what now? ANSI left right outer join and non-ANSI. Okay, so now. Okay, fine. The next one is called as what now? Third one, full outer join. Full outer join. Full outer join, it means what, sir? Means that, careful observe. It is a combination of left outer and right outer joints. Okay, na? Combination of left outer and right outer joints. Okay. Now, by using full outer join, what we can do by using full outer join? We can retrieve or retrieving. We can retrieving, matching, and also unmatching rows from multiple tables at a time. Okay, now? So full outer join, the advantage is what now? We didn't lose any type of data. We are getting matching data as well as unmatching data. The both data we are getting here. Okay, that is advantage of full. Because of reason, full outer join nature is what now? It is a combination of left outer and right outer. Okay. Now we can see on this table, if I'm using the full outer join key, I'm applying now. Okay, now we can see output. When you see the output here, all are coming to you. So 1, 1, 1, 1, 2, 2. This is matching data. 1024 word, it is unmatching data from student table. And 3.NET 45, it is unmatching data from course table. So matching data scheme, unmatching data from left side table, unmatching data from right side table. So completed tables will come to you. Okay, na? Now both kind of data we are retrieval or not? Okay, this is full outer join ANSI format, how to write. Now tell me guys, can you write ANSI format? Sorry, can you write non-ANSI format? Any guessing? How to write a non-ANSI for full outer join? So both sides we want to use plus operator. So both sides we want to apply plus operator. Okay. Let me see. I'm going to try this. Select a star from students, comma, course. And here I will give student yes. Next to course C. So where S.CID of plus operator is equals to C.CID of less operator. Okay. So many people expecting this now. No. Then what we are expected? Okay. Let me see. If I'm going to give this one, what it was happening, you can see. It was showing error. What is error? Can you see error? A predicate may reference only one outer join table. That means whatever I'm using this join operator to predict purpose, this symbol can be used on any one table. Any one table only, but both sides we cannot. Both sides we cannot. Then, is there any solution here? Because here, careful observe, definition read. It is a combination of a left outer and right outer. Left outer is what now? Non-ANSI format. This is left outer join. Okay, I'm taking now. I'm taking left outer join. Next, I'm taking right outer join non-ANSI format. Okay, right outer join non-ANSI format. So left outer, it is a combination of left outer and right outer. So this is left outer. This is right outer. So both I'm taking. Then both should be what I want to do, combined. Both should be combined. Combined means, do you have any operators we discussed to combine two select queries? Two select queries combining. Is there any operator? Very good. Union operator is there. Which operator? Union. Yes or no? Set operator union. So I want to use here union. Okay, let me see how to write now. So this is left outer union. This is right outer. Right outer. The two selected statements I joined. Then got it? Your full outer join is implementation is over. Okay. This is what we called as a full outer join in non-ANSI format. How to implement now? Non-ANSI. Okay, now. So these are the outer joins mechanisms, guys, here. So as of now, equi join, non-equi, outers. These three types of joins we discuss. And remaining three was there. So self join, cross join, natural join. So these three joins we will discuss in tomorrow session. Okay, now in tomorrow session we will discuss the remaining three joins. Okay, right. And today in this class, having any queries, so you can stay there and ask your queries. If there is no queries, log out.